Well, a strong red tide bloom is causing problems along the Texas coast, killing sea life and even making it hard for beachgoers to breathe.
The Texas plains are a monument to stillness, where the horizon seems pinned by nothing but gravity. But deep beneath the cattle ranches, something ancient has begun to stir. A relic from a time before dinosaurs even existed. It is a 300-million-year-old anomaly, a jagged scar in the bedrock that should be dead. Yet, it is screaming back to life with a terrifying intensity. We have accidentally reawakened a prehistoric ghost, and the consequences are shaking the very foundation of the Earth. Deep Time's dark secret. In the winter of 2017, a team of seismologists led by Dr. Beatrice Magnani from Southern Methodist University published a study that shattered the long-held perception of Texas as a geologically immortal landscape. For decades, the rolling plains of the Lone Star State were considered part of the stable interior of the North American continent, a place where the Earth was so solid and ancient that the very idea of a major earthquake seemed like a scientific impossibility. However, after a series of mysterious tremors began rattling North Texas towns like Azle and Irving, places that had never experienced seismic activity in recorded history, the scientific community knew something was fundamentally changing beneath their feet. They deployed advanced seismic reflection technology, a high-tech method of seeing through miles of solid rock using sound waves to create a detailed map of the subterranean world. What they discovered was not just a minor crack in the crust, but a massive, 300-million-year-old anomaly that challenged the very definitions of life and death in the field of geology. The scans revealed a vast network of faults buried deep within the crystalline basement rock, the foundational bones of the continent. In geological terms, a fault is typically categorized based on its history of movement. If a fault hasn't slipped in 10,000 years, it is often considered dormant, and if it has remained still for millions of years, it is effectively declared dead. The faults identified by the SMU team were in a category of their own, having remained utterly motionless for at least 300 million years. These were features forged during the assembly of the supercontinent Pangaea, a time when the Earth's land masses were violently colliding to form a single giant continent. Once that collision ended, these faults locked into place, sealed by the immense pressure of the overlying strata and the passage of eons. They were supposed to be permanent fixtures of the past, as immovable as the core of the planet itself. The terrifying nature of the discovery lies in the pristine state of the geological record that these scans uncovered. When researchers look at active seismic zones like the San Andreas Fault, they see a chaotic mess of broken rock layers, where every earthquake has left a visible scar, shifting the Earth's layers like a deck of cards that has been shuffled thousands of times. But in the North Texas seismic scans, the layers of rock were unnervingly straight. For 300 million years, the sedimentary layers of the Earth had piled up on top of these faults like perfectly leveled bricks in a wall. There was no evidence of a single flinch, no sign of a tremor, and no indication that these faults had moved even a fraction of an inch since before the first dinosaurs walked the Earth. This meant that the region was naturally one of the most stable places on the planet. Yet, the scans showed a violent, jagged break in the very newest layers of the Earth, the layers deposited in the last few thousand years. This was a geological anomaly of the highest order, a dead system that had been suddenly and unnaturally resurrected. The data suggested that the Earth wasn't failing because of natural tectonic stress, but because the foundational integrity of the basement rock was being compromised from the outside. To see a fault that has survived the rise and fall of the dinosaurs, the ice ages, and the shifting of entire continents suddenly snap in the 21st century is the equivalent of watching a fossilized skeleton suddenly stand up and walk. The researchers realized that these faults were not creeping or slowly adjusting to natural pressures. Instead, they were reacting to a new, modern stimulus that was bypassing 300 million years of geological precedent. The sheer scale of the anomaly implies that the stability we take for granted is far more fragile than we imagined. If a 300-million-year-old fault can be forced back into action, it means that no part of the continental interior is truly safe. The bedrock of Texas, once thought to be an immovable anchor, was revealed to be a complex machine of ancient gears that had been rusted shut for hundreds of millions of years, only to be forced back into gear by a new, invisible hand. This discovery turned the scientific understanding of stable regions on its head. It proved that dead faults are not actually gone. They are simply waiting in a state of high-tension equilibrium. The SMU study provided the smoking gun that these ancient scars were being reactivated by human activity, specifically the high-pressure injection of millions of gallons of wastewater into the deep underground. This fluid acts as a lubricant, seeping into the ancient, dry cracks of the 300-million-year-old anomaly and reducing the friction that has held them in place since the Paleozoic era. When that friction drops, the massive tectonic stress that has been building up for millions of years is suddenly released in a single violent burst. The terror of the anomaly is the realization that we have inadvertently poked a sleeping giant that was never supposed to wake up. We are now living on top of a resurrected prehistoric landscape, where the very ground beneath our homes is being dictated by the movements of a ghost that has been haunting the Texas plains for 300 million years. The origin of these ancient scars lies in a world of monsters and colliding worlds that existed long before the first human map was ever drawn. The Permian Ghost. To understand the true weight of the 300-million-year-old anomaly, we must peel back the layers of the Texas soil and journey into a deep-time nightmare known as the Carboniferous and Permian periods. This was an era of planetary transformation so violent that it makes our current geological age seem like a period of absolute stillness. Long before the first flowering plant or the first dinosaur, Texas was not a land of dry plains, but a chaotic intersection of tectonic forces. The world was witnessing the slow-motion collision of the Earth's great landmasses, Gondwana and Laurasia, as they ground against one another to forge the supercontinent of Pangaea. This was the forge in which the Texas basement was hammered out. As the continents collided, the immense pressure buckled the Earth, creating deep, jagged tears in the crystalline crust. These were the birth cries of the faults found in the SMU seismic scans, massive tectonic scars that reached miles into the dark interior of the planet. The environment of Texas during this time was a surreal landscape of extremes that shaped the rock we stand on today. It was a world of sweltering heat and oxygen-saturated air, which allowed life to grow to terrifying proportions. In the swamps that would eventually become the state's coal and oil fields, dragonflies with the wingspans of hawks patrolled the skies, and 6-foot-long millipedes scurried through the undergrowth. Beneath this prehistoric theater, the crust was under a state of unimaginable tension. The faults were being loaded with energy as the Appalachian Ouachita Mountains were pushed skyward by the continental crush. When the movement finally stopped about 250 million years ago, the faults didn't disappear. They simply locked. They became a fossilized tectonic system, a network of structural weaknesses that were buried by miles of sediment as the Permian seas advanced and retreated, depositing the thick layers of limestone and salt that now house the region's vast energy reserves. This era ended with the Permian-Triassic extinction, often called the Great Dying, where nearly 90% of all life on Earth was wiped out. While life struggled to restart, the faults beneath Texas remained in a state of suspended animation. They were the silent witnesses to the rise and fall of the dinosaurs, surviving the breakup of Pangaea and the shifting of the modern continents without ever slipping again. For 300 million years, the friction generated by the weight of the world above was enough to keep these ancient gears frozen. They were effectively removed from the geological clock, becoming a permanent, unmoving foundation. This is why their sudden reawakening in the modern era is so biologically and geologically jarring. It is as if a piece of the Paleozoic world has been resurrected to haunt the Anthropocene. Geologists refer to this deep-seated rock as the basement for a reason. It is supposed to be the indestructible floor of the continent. The 750 million-year-old history of the North American craton suggests that once a region like North Texas becomes part of the stable interior, it is retired from the active duty of earthquake production. The faults we see in the seismic scans are the ghosts of those ancient mountain-building events, structural scars that were healed by time and pressure. They represent a version of Texas that was once as tectonically volatile as the Himalayas. By uncovering these faults, scientists have realized that the stability of the Great Plains is actually an illusion. We are not living on solid ground. We are living on a giant, shattered mirror that has been glued together by nothing but time and the absence of water. The sheer longevity of this dormancy is what makes the anomaly so profound. In most parts of the world, a fault that hasn't moved in a million years is a curiosity. one that hasn't moved in 300 million years, is a monument. These structures were built to last forever, designed by the crushing forces of a supercontinent to stay shut until the end of the world. The fact that they are now sliding is a testament to how deeply human activity has penetrated the Earth's natural defenses. We have reached back into the Permian period and flipped a switch that was never meant to be touched. The Permian ghost is no longer a silent part of the fossil record. It is an active participant in the modern world, reminding us that the deep past is never truly dead. It is just waiting for the right conditions to return. This prehistoric silence was finally shattered when we began pumping the waste products of modern industry into the very veins of the ancient Earth. The terrifying reawakening. The transition from a dormant geological monument to an active seismic threat is not a matter of natural evolution, but a direct consequence of a massive, unintentional plumbing experiment conducted on a continental scale. To understand why these 300-million-year-old faults are suddenly sliding, one must look at the physics of induced seismicity, a process that essentially turns the Earth's crust into a lubricated machine. For 300 million years, the ancient faults beneath Texas were held shut by two primary forces: the immense weight of the miles of rock pressing down from above, and the jagged, dry friction of the fault surfaces themselves. They were effectively rusted shut by the passage of time. However, the modern energy boom in the Permian Basin and North Texas has introduced a new variable into this prehistoric equation: the injection of millions of barrels of salt water into the deep subsurface. This water is not a primary product of fracking itself, but rather a toxic byproduct known as produced water that comes up from the earth alongside oil and gas. Because this water is hypersaline and laden with chemicals, it cannot be dumped on the surface. Instead, it is pumped back down into disposal wells that reach thousands of feet into the ground, often terminating just above the crystalline basement rock where the ancient faults reside. As this high-pressure fluid is forced into the deep strata, it begins to migrate. It fills the microscopic pores and cracks of the rock, acting as a hydraulic jack that pushes against the walls of the faults. This process, known as pore pressure increase, reduces the effective stress that keeps the fault faces squeezed together. In simpler terms, we are injecting a lubricant into a 300-million-year-old gear system that hasn't seen a drop of moisture in eons. The terrifying reality of this process is that it doesn't take much to trigger a catastrophe. The faults are already under immense tectonic stress, like a tightly wound spring that has been held back for millions of years. They are critically stressed, meaning they are right on the edge of failing, held in place only by the thin margin of friction. When the injected wastewater reaches these structures, it provides the final nudge. It unclogs the fault, allowing the two sides of the rock to slip past one another in a sudden, violent release of energy. This is why the SMU seismic scans were so alarming. They showed that the earthquakes weren't happening in the shallow layers where the drilling occurs, but miles deeper, in the heart of the ancient basement. We are effectively sending a signal through the rock that is waking up structures far below our reach, creating a chain reaction that we cannot stop once it has begun. Furthermore, the scale of this fluid injection is staggering. In parts of Texas, companies have been injecting hundreds of thousands of barrels of water per month into a single well. Over years, this creates a pressure bulb that expands outward through the rock, traveling miles away from the original injection site. This explains why tremors often begin years after a well has been established, and why they can occur in towns that don't even have active drilling rigs. The fluid is a slow-moving messenger of chaos, creeping through the 300-million-year-old cracks until it finds a point of least resistance. Once the pressure hits that sweet spot, the Earth snaps. The resulting earthquakes are not man-made, in the sense that we are creating the energy. The energy was already there, stored in the rock since the time of Pangea. We are simply the ones who pulled the trigger on a loaded gun that has been aimed at the surface for 300 million years. What makes this reawakening particularly terrifying to geologists is the lack of predictability. Because these faults were hidden and silent for so long, they weren't on any modern seismic maps. We didn't know they were there until they started moving. This means we are operating blindly, pumping fluid into a basement that is far more fractured and dangerous than anyone realized. The SMU study proved that the anomaly isn't a localized fluke. It is a systemic failure of the geological seal that has protected this region for hundreds of millions of years. We have essentially broken the lock on the Texas basement, and the pressure continues to build. Every gallon of water pumped into the earth is another potential drop of lubricant for a prehistoric machine that was never meant to be restarted. And the more we pump, the more of these ancient ghosts we invite back into the living world. This mechanical failure of the Earth's crust invites a chilling comparison to the last time these faults were active, a period defined by the greatest extinction event in the history of our planet. Echoes of the Great Dying. The terrifying nature of the 300-million-year-old anomaly is not merely found in the shaking of the ground, but in the dark historical symmetry it shares with the Permian-Triassic extinction. Geologists often look at the present through the lens of the past, and the reactivation of these specific faults carries a haunting resonance with the Great Dying, a period 252 million years ago when the Earth's crust was so unstable that it nearly extinguished life entirely. When these faults were originally active, the planet was undergoing a radical transformation characterized by massive volcanic eruptions and the catastrophic release of carbon from the deep interior. Today, by piercing the Texas basement and forcing these same faults to slide, we are essentially mimicking the tectonic stresses that once defined a dying world. We are playing with the same geological machinery that was responsible for the most profound biological collapse in history, reopening wounds in the earth that have been scabbed over since the dawn of the dinosaurs. The SMU seismic scans show that the stress being released today is not a new creation, but the discharge of fossil energy that has been stored within the basement rock since that era of global catastrophe. During the Great Dying, the movement of the Earth's plates caused the crust to fail on a global scale, leading to the eruption of the Siberian traps and a runaway greenhouse effect. While the current tremors in Texas are localized and smaller in magnitude, the mechanism is eerily similar: the breach of a stable geological seal. In the Permian, it was heat and magma. Today, it is high-pressure fluid. Both forces achieve the same result by overcoming the internal friction of the planet's oldest rocks. The comparison is terrifying because it suggests that the stability of our current geological epoch is not a permanent state, but a fragile equilibrium that can be tipped back toward a more violent, Permian-like state of flux. There is a profound irony in the fact that the very oil and gas we extract from the Permian Basin, the remnants of the life that survived or perished during that ancient extinction, is now the catalyst for reawakening the faults that define that era. We are using the chemical energy of the past to physically disturb the structural foundation of the present. The basement of Texas was supposed to be a tomb, a place where the violent history of the Paleozoic was buried under miles of protective sediment. By inducing seismicity in these 300-million-year-old anomalies, we are essentially exhuming a tectonic corpse. The seismic scans act as a warning that the Earth's memory is long, and the scars of the Great Dying are still sensitive to pressure. We are finding out that the planet does not truly forget its traumas. It simply hides them under the weight of time, waiting for a catalyst to bring them back to the surface. This connection to the Great Dying also highlights the fragility of the Texas basement rock itself. We often think of the ground as a solid, monolithic block, but the scans reveal it to be a complex, shattered mosaic. For 300 million years, the glue holding that mosaic together was the absence of lubricating fluids and the immense pressure of the overlying rock. By introducing wastewater into this delicate system, we are dissolving the geological glue that has kept the Texas plains safe for more than 100 million years longer than dinosaurs existed. The terrifying part of the discovery is the realization that we are not just causing small earthquakes. We are degrading the structural integrity of the continental plate. We are poking at the same faults that once witnessed the near-total destruction of the biosphere. And in doing so, we are learning that the line between a stable world and a chaotic one is much thinner than we ever dared to believe. For the people living above these resurrected ghosts, the abstract science of the Permian is translated into a very real and immediate fear: the human toll. For the residents of North Texas towns like Azle, Reno, and Irving, the 300-million-year-old anomaly is not a laboratory curiosity. It is a violent intruder in their living rooms. For generations, People moved to these plains precisely because the Earth was dependable. Unlike the precarious cliffs of California or the volcanic ridges of the Pacific Northwest, North Texas was a place where the foundation of a home was a lifelong guarantee. That social contract was shattered starting around 2008, when the first tremors began to roll through neighborhoods that had never felt the Earth move in recorded history. The psychological toll of this reawakening is profound. There is a specific kind of dread that comes with the realization that the most stable thing in your life, the ground beneath your feet, has become unpredictable. People who once slept soundly began to lie awake, listening for the low subsonic rumble that precedes a strike from the Permian ghost. The stories from these communities are hauntingly consistent. Families describe the terrifying sound of an earthquake in a stable zone as being less like a roll and more like an explosion, a sudden bang that feels as though a truck has slammed into the side of the house. In towns like Azle, which sat directly above the newly lubricated faults, the frequency of the quakes became a relentless assault on the senses. Chimneys began to pull away from exterior walls, and jagged cracks, reminiscent of the faults themselves, began to spiderweb through drywall and concrete slabs. This physical damage to property is mirrored by a decline in the sense of security. In a region where earthquakes are not part of the cultural DNA, there is no infrastructure for seismic resilience. Schools, hospitals, and bridges were built with the assumption that the 300-million-year-old silence would last forever. Now, every tremor raises the terrifying question of whether the Big One is lurking in a basement that was once considered dead. The human cost is further complicated by the invisibility of the enemy. Because the faults are miles deep and were only revealed by specialized seismic scans, residents felt for years that they were being gaslit by officials. Before the SMU study provided the definitive link to wastewater injection, many were told the shakes were a natural anomaly or a statistical fluke. This created a rift between the community and the industries that drive the local economy. Neighbors were pitted against neighbors as the very industry that provided jobs and tax revenue was revealed to be the hand that was poking the prehistoric giant. The terror is not just in the shaking, but in the realization of human powerlessness. Once the high-pressure fluid has been injected into those ancient cracks, it cannot be vacuumed back out. The pressure bulb continues to move through the rock layers long after the pumps are turned off, meaning the residents are living on a geological time bomb with a fuse that has already been lit. In Irving, a suburb of Dallas, the tremors were particularly unsettling because they occurred in a densely populated urban corridor. The sight of office workers evacuated onto the streets of a Texas city because of an earthquake felt like a scene from a dystopian film. It forced a collective reckoning with the reality that our technological reach has exceeded our grasp of the consequences. We have invited the volatility of the Paleozoic era into the modern urban landscape. For the parents in these towns, the anomaly is a shadow over their children's future, a permanent change to the environment that cannot be easily undone. The ground is no longer just dirt and rock. It is a living, breathing system of ancient scars that we have accidentally resensitized. The human toll is the loss of the most basic human certainty, the belief that the world is solid and the past is truly behind us. This local suffering is a microcosm of a much larger warning, a final revelation about the relationship between human industry and the deep time of our planet. Earth Unlocked. The discovery of the 300-million-year-old anomaly beneath the Texas plains serves as a profound memento mori for the modern industrial age. It is a stark reminder that our planet is not a static stage upon which the human drama unfolds, but a complex, reactive organism with a memory that spans eons. The SMU seismic scans have pulled back the curtain on a terrifying reality. The stability we rely on to build our cities and sustain our economies is merely a temporary pause in a much longer, more violent geological narrative. By reawakening these ancient faults, we have demonstrated that human agency has reached a level of power comparable to the tectonic forces of the Paleozoic. We are no longer merely living on the Earth. We are fundamentally altering the mechanical balance of its deepest foundations, reaching back into the graveyard of the Permian to disturb a peace that was meant to be eternal. The true terror of this discovery lies in the permanence of the change. Once the high-pressure wastewater has infiltrated the crystalline basement, the friction lock that held the Texas plains still for 300 million years is effectively broken. We cannot reach 3 miles down to dry the rocks or to stitch the fractures back together. We have entered into a new era of geological uncertainty where the lessons of the past no longer provide a reliable map for the future. The Anomaly teaches us that deep time is not a distant, dusty concept found only in textbooks, but a pressurized reality that exists just beneath our feet. The ghosts of Pangaea are not gone. They were simply resting, and our search for energy has provided the spark they needed to return to life. This scientific revelation forces a humbling reassessment of our place in the world, shifting our perspective from masters of the landscape.
Thank you for being with us this midday. I'm Kara Sewell. So those maps, again, just got released within the last hour.
As we look to the future, the Texas Anomaly stands as a sentinel, a warning to other regions of the world that consider themselves seismically immune. The geological basement of every continent is riddled with similar ancient scars, thousands of miles of dormant faults that have been silent since the continents first took their modern shapes. If the stable interior of Texas can be compromised, the same logic applies to the vast plains of Russia, the heart of Australia, or the central reaches of Brazil. We are discovering that the Earth's crust is a global network of loaded springs, and our industrial processes are the fingers on the triggers. The 300-million-year-old anomaly is not just a Texas story. It is a global cautionary tale about the unintended consequences of disturbing the deep Earth. It is a call for a new kind of geological stewardship, one that respects the silence of the ancient world. Ultimately, the tremors of the Texas plains are the heartbeat of a resurrected giant. They remind us every time the ground shakes that the Earth is a vessel of immense, hidden energy, and that some things are better left buried in the depths of time. We have poked the sleeping giant of the Texas basement, and in its stirring, we find a terrifying mirror of our own impact on the planet. The foundation is moving, the silence is broken, and the 300-million-year-old ghost is finally, hauntingly, awake. Subscribe to our channel to unlock more mysteries.